Hello children, this is Dr. Lai here. This is one of the many videos that I am making to help you to prepare for PSLE. Today we are talking about electricity. Do you have any trouble answering these questions? If you have problems with these questions, you have come to the right place. Today I am going to show you one electrifying strategy to handle these problems. Are you ready for it? And the electrifying strategy is trace the path. What do I mean by trace the path? It means tracing the path from the battery to the bulb and back to the battery again. The path must contain battery because battery has chemical potential energy which will be converted to electrical energy in the wire provided that the path is closed. Now let me repeat this strategy again. You have to trace the path from the battery to the bulb and back to the battery again. What do I actually mean by closed path? It is actually a closed circuit. Current can flow and the bulb will light up. If this is a closed path, there won't be any electrical insulators along the path. Electrical insulators prevent the current from flowing. This is an example of a closed path. This is the closed path. The bulb will light up because there is no electrical insulators along the path. Can you think of some examples of electrical insulators? Here are some examples of electrical insulators: wood, plastic, and air. A fuse or blown light bulb can be an electrical insulator too. Why is that so? Observe these two bulbs carefully. Can you see why the fuse or blown bulb is an electrical insulator? In the fuse bulb, there's a gap here. The gap is actually the air. Because of the air here, this makes the fuse or blown bulb an electrical insulator. Why is an open switch an electrical insulator too? Observe the closed switch and the open switch. Can you see why open switch is an electrical insulator but not the closed switch? Like the fuse bulb in the previous example, there's a gap in the open switch, and this gap is actually the air. And because of the air, the open switch is an electrical insulator. Now, let's recap what we have learned so far about this electrifying strategy. We have to trace the path from the battery to the bulb and back to the battery again. If it is a closed path with no electrical insulators, the bulb will light up. Like this, the bulb will light up because there's no electrical insulators along the path.